Hey guys, I hope you're doing well and thanks for checking out today's video about the 30, 60, 90 triangle. So this is one of our two special right triangles and the other is that 45, 45, 90 triangle. And 30, 60, 90, that refers to angle measurements. So what I'm saying is that it's a triangle where we have a 30-degree angle, a 60-degree angle, and a 90-degree angle, our right angle. And what's special about these is the ratio of side lengths in these triangles is always going to be the same and they're pretty simple to memorize. So let's take a look at what I mean with this 30, 60, 90 triangle. So what we have is the side lengths are represented by x times certain variables. We have square root of 3 and 2, and x represents the shortest side. So it's important to note that this is always going to be the side opposite of the 30-degree angle. So the shortest side is going to be opposite that 30-degree angle because the smallest angle corresponds to the smallest side. And then we have the longest leg. That's what we call these that are not the hypotenuse. The longest leg, that is x times the square root of 3. So you take that shortest angle, the shortest side, and you multiply it by the square root of 3 to get the longest leg. And then finally, we have the hypotenuse, which as you know is always opposite the right angle. And this is 2 times that shortest side. So this is going to be the longest side on the triangle, and it's just 2 times the shortest leg. I'm going to say shortest leg instead of shortest side. Both work, but I just like leg a little bit better. So now I want to show you guys why this works. So why can't I just use this ratio all the time? Well, we have to go back to the Pythagorean Theorem that we talked about earlier. Remember that says that a squared plus b squared equals c squared. And this was a theorem that only worked for right triangles. So we do have a right triangle because we have that 90-degree angle. So this applies here. And remember that a and b were the legs. So these are the legs of the triangle. And then c is the hypotenuse. So I'll just say hyp. So the legs are a squared, a and b. And so the shortest leg will make x. So that'll be a. So we have x. And then we're squaring it. So x squared plus now b. This is important. B is not... You need to put it in parentheses because we're going to have to square everything. So it's really important to group them together, and that's something a lot of students mistake. So let me cancel this really quick. Sorry about that. So we get x square root of 3 quantity squared. So what we can do, and then we get c, and now that's going to be, again, you need to group it together. C is 2x, and we're squaring the entire thing. So x squared, not really going to simplify that. That'll just stay as x squared. But then we have x square root of 3 squared, and what's important is that this squared needs to go to everything. So I need to bring it to the x, and I need to bring it to the square root of 3. So I'll get x squared, then square root of 3 squared. Remember that if you square something that is a square root, they just cancel and you get the number. So it's x squared times 3 equals, and now again the 2x squared is going to be 2 times 2 squared, and then times x squared. So 2 squared is 4x squared. So that's what we have there. And now we can rewrite this just because I don't like it as x squared root of 3. It makes more sense as 3x squared equals 4x squared, and that looks correct to me. So we get 4x squared equals 4x squared, and that is why it works, why these ratios of side lengths are correct, and that's why you can have this special triangle. So hopefully that makes sense. Now we're going to get into some practice problems that hopefully will clear this up a little bit. But for now, just note the side lengths and try to memorize them as you go. So we have x is the short one, x square root of 3 is the longest leg, then we have 2x for the hypotenuse. So let's get started. Here in our first example, we have a triangle here where we're given a little bit of information, not much, but we actually can infer that this is a 30, 60, 90 triangle. So let's try to take it step by step and figure out how we'd be able to figure that out. So the first thing I see is we're given one angle measurement, but we're also given this symbol here, which means that that's a right angle. So we can actually figure out the last one by doing the 180 rule. So the angles in a triangle have to add up to 180. So if I'm given 2 of them, I can do 180 equals 90 for the right angle plus 30 plus, we'll make that y. That will be this last angle. And I get 180 equals 90 plus 30 is 120 plus y. I'm going to subtract 120 from both sides, and then I'll get y equals 60. So 60 equals y. And then I have my 30, 60, 90 triangle, and now is when I can really figure out the rest of the side lengths using those rules we talked about earlier. So let's think about, we're given one side length, and which one is that? Well, it's opposite the right angle, so that means that 6 equals the hypotenuse. And remember, the hypotenuse equals 2x. So I'm going to write this over here. I have 2x equals 6. I'm going to divide by 2 to figure out what x is. I get x equals 3. And that's really good because now I can solve the rest of it pretty easily because I know the shortest side, shortest leg, equals just x. So that's easy. So that's going to just be that 3. We're going to plug it right in. Then the longest leg is the other angle that I don't have, the other side length that I don't have, I should say, is x times the square root of 3. Well, that's just going to be 3 times the square root of 3. So now I have all the side lengths. The last step is to figure out, well, which one goes where. And this is when we need to think about that, what I was talking about earlier. Well, the shortest leg is always going to be opposite the shortest angle, which is always going to be the 30 in these triangles. So the 30 side is going to correspond to that shortest leg, which corresponds to x, which is 3 in this example. So this is 3. Then the longest leg will be that x square root of 3, which is 3 square root of 3. So, and that corresponds to the 60. So there's our triangle, and we can solve it. And I recommend that you take the time to go through the Pythagorean Theorem and make sure this is correct, and hopefully you'll see that it is. And so that's what's helpful about this, that it makes these go a little bit quicker than if you had to use the Pythagorean Theorem normally. So now we have one more example, and this one's a little bit tougher to even realize that it is the 30, 60, 90. All we're given is the 90. We're given a 90-degree angle, so we know it's a right triangle, so that helps. But we don't know if it's a 30, 60, 90 yet. We have to figure that out. We're given the two side lengths, and notice that they're both the legs, and we're given 2 and 2 square root of 3. 2 and 2 square root of 3. Well, when I see the square root of 3, I think, well, wait, the ratio from the side lengths before was x and then x square root of 3. Remember, the short side was x, so I'll just say short. And then the long leg was x square root of 3. Well, I can tell that these are related and that x just equals 2. So x is equal to 2, so that means that the hypotenuse, the side that we don't know yet, that always equals 2x. Well, it's just going to be equal to 2 times 2, which is 4. So that's going to be this right here. And then now I can calculate, I can just write in where the 30-degree angle is and where the 60-degree angle is by thinking about my rules. So remember that the short side corresponds to x, short equals x, and then long equals x squared root of 3. So, and remember the short angle is 30 degrees and the long angle is the 60-degree angle. And so here's 60 must be here because that's the 2 square root of 3. And then the 30 must be here because that's just the 2. So now I have my triangle 60 degrees, 30 degrees, 90 degrees. That's my 30, 60, 90. Hopefully you understand this now. Hopefully you're starting to get a feel for it. These can really be helpful because they make solving these problems a lot faster if you can get used to recognizing them and things like that. So thanks for watching. Let me know if you have any questions.